with Ruby.
Hello, Ruby friends. I'm Kei Sawada. I Twitter ID Timor and the author of Burn Ruby Gem. So today I'm going to talk a little bit about Burn Ruby Gem, and so we can create a NES application with Ruby DSL. Okay. So what on earth is Burn? Firsthand. Burn is a Ruby gem which enable you to create your own NES-ROM image file or the Telnet sub application from Ruby DSL. Just write one text file, then you can create the NES-ROM or the Telnet sub application. So I'm going to do some demo from now. Just to note, Burn works fine with the Windows or Mac or Linux as long as Ruby version over than 1.9.1 works. But I'm not sure if it works with JRuby or Ruby News. Not yet tested just. And right now the latest version is version 0.2.2. Okay, so I'm starting some demo. Wait. Okay. So the first demo should be the NES-ROM compilation. Are you hearing me? Okay. Cool. This is just bash. Wow. Okay. And I've already cloned the Burn Ruby repository from GitHub and changed directory. Okay. Then go to the example folder. And today I'm going to test some shooting game. And just so you can see that in this folder, actually this temporary folder is not needed, so just delete it. So you can see there is only the Ruby main.ruby. It's a simple DSL. Maybe I can tell you some later. But just type command here. Then burn command takes that Ruby gem Ruby file as the input, and then this is the output. Thank you. Okay, actually you can play like this. It's actually this is JS Nest. This emulator is not created by me, just the open source. Low tech, but enjoyable to me. Something like this. Okay. Okay. Next demo is maybe I need to show you some the editing. So actually, wait. Okay. Okay. What I'm going to do is actually release. What was that? Burn. Okay, this main.nes file is the created from Burn, and I'm right now just doing backing up. Okay, then next I'm going to do some. Again, please remember this song. I will change this opening song from now on. I will sound edit, and also look this character. Press start. I will also edit character this. Okay. How to edit this is actually it's very simple. So the display means that what song do you want to play? So here I will change to some song. Actually, I've composed yesterday during the RubyKaigi day 2, and the song name is this one, Hoover Purple. Okay. Well, this one. I should say here Hoover Purple here. I wish the spell is okay, purple. Okay. And also where is the hello world? No, press start. Okay. Press start. Okay, here. The label I found this one. Maybe this one. So, okay, press let's say RubyKaigi. Let's see if this works. Hopefully. And the press RubyKaigi changes. Okay. It's a deep up or burn. Okay. Anyways. Then next I will show the binary comparison. So actually what happened? Okay, I'm opening the hex friend and what file I should open now? Maybe example, and here I was in and first I open this one. It's the actual NES-ROM file, and next I also open another file to compare. Okay. Actually, I backed up earlier, which is I wish maybe there should be some. Yeah, I think this one. Okay. And compare. Okay. This is the binary comparison. Maybe you can, even I easily cannot find the difference, but there is some difference, right? So actually, I guess not so much difference, but I guess this one represents the play song pointer or something like that. Okay, anyways, this is the one demo for the NES-ROM. And no time to show everything, so just to go to the next example. Okay. Next example is a Telnet server. So actually, I'm not sure if the network works fine. But if you have your laptop, then you can try something like this. So feel free to telnet this IP, global IP, which is my server, and I'm running some telnet server on the port 60,000. So if you'd like to see, you can see something. But also I'm showing this. It's just a small demo, and no. TTY play. Just I've recorded, so I'm showing this. TTY play. TTY record, I think. Oh, it's not good, I think, because maybe the screen resolution, I think. Okay. Maybe I should use different terminal. Although there is no time, but try. TTY play, TTY record. Okay, I use some terminal here. Works? Okay. This is just a recorded, but yes. So, okay, we've seen that from the Ruby DSL, we've successfully translated it to the .NET-ROM file or the Telnet sub application. And this year I released this, actually, from all over the world. Some geeks like this, and I'm really proud of that, and thanks to them. And on the Hacker News, I announced, then someone says that, okay, it's amazing, or the very, very cool, and I'm proud of that. Also, I posted the release to the Reddit. Then someone said the coolest shit is always the most useless. Yeah. Thank you so much. Yeah. I know that. So I know this, but I have a reason to create this. So later I will explain this. Okay. So Today, I'm going to explain the three contents. The first one is the .NET compilation process, and the second one is the NES server architecture. And the last three, I will explain the reason why I created this gem. When it comes to the compiling this application, CC65 binaries works pretty fine to me more than anything. Actually, the Ruby gem file contains CC65 binaries in the gem file. That's why gem file is a little bit big file size. Maybe it is right now 2.3 megabyte or something like that. Inside Burn, workflow will look like this. So first, you've seen that fuel. We call the Ruby DSL, our Ruby DSL as fuel because we can burn it. Okay, and we input that fuel to the burn gem file. First, this one like this. So it goes to the preprocessor. Actually, maybe I should use this pointer. Right. And next, preprocessor will create some intermediate files. And actually, you can see that there is a C file. So actually, Burn create the C file as intermediate language. Okay, and other .s files is some assembly language file. Also, as well as this lib is the library file to compile and link these objects. And lastly, Burn will use these intermediate files, and CC65 will take these intermediate files as to compile and link. So finally, you get the main.NET file. And after this, I run some Fabric web server, and you can see that emulator works. Okay. Let's see next what is the main.NET? What was that main.c file look like? I'm sorry, but I'm just show some C burn example. What was that? Ruby was yes, and temporary main.c. This is the intermediate file Burn created just now. And open this, so you can see some include and some predefined functions, which is the predefined. So you don't have to do anything with this and blah, 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 blah. What is important is this one. So in the main function, you can see, so these are the part where you've converted from the Ruby DSL to C language. Okay. So with Burn Ruby gem, you can create really easy NES file, so that I recommend all of you to create some custom ROM and give them to your girlfriend or boyfriend as a special gift, maybe. That's really nice. I really recommend that. Okay. Anyways, this is assembly. Maybe I don't have enough time to explain this, so that if you have any questions, so just ask me later. The interesting point of the NES compilation is this one, Ruby DSL translation. Okay. This is the DSL. You love DSL, I know, and I love it as well. And this part, I just use instance eval to make use of these DSLs, and that's more or less no problem, just fine. And you know very much about the dynamic programming, I think, and I don't need to explain very much, I think. But I guess maybe I need to explain this part, main loop. And some strange string is set to here. You can see that it says main loop, so that you can easily imagine that this main loop part will be converted to the while loop. Okay, please imagine that. And in the while loop, these two lines of codes will be inserted. Actually, then what is ugly about this is originally I wanted to do here I wanted to use the block syntax here. So main loop do and frame blah 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 will be really nice Ruby syntax. So initially I was really aiming to do that, but finally failed because I cannot parse the block data on memory to the, and I cannot successfully convert the block part data to the C syntax. But instead, I could do the string, this string, to convert this string to C language. That was successful thanks to the Reaper. So that's why I decided to use here the ugly syntax. This is ugly, but the works so far, it's okay. It's really childish and only do some simple translation, but it's still okay. What I'm doing here is actually yesterday you might already hear about the Reaper, and because there was presentation about the power assault, and I think he knows very much about Reaper. So same as him, I use the Reaper S expression method, and so I get this kind of array, and I parse this array to this C syntax program. It looks similar, but semicolon is not here, or the double quote here, or something like this. So converted successfully. So that's why I've successfully converted the NES compilation. Yes, it's really quite fine, but there is many limitations. This is only simple implementation. I have to note about that. For example, you cannot use the function here, define. You cannot do, or also, of course, you cannot use the class, or many. Only you can do some simple computation like the plus, minus, multiple. But for the basic implementation, maybe those should be enough. Actually, at least to me, it's enough so far. If you need more, then maybe you can implement and maybe send me the pull request. It's really welcome. Okay, that's the simple summarized explanation about the .NET compilation process. Next, telling us about architecture. So what about the telnet? Before telling you the high-level architecture, I need to mention. So in the NES compilation, sorry. Oh, okay. In the NES compilation, what we did was the Ruby DSL to the C language. Okay, but for the telnet server, application server. Next, okay. What I did is the Ruby to Ruby. So it's more simple. Ruby DSL to this one is the converted, but you can see apparently different. Maybe it's too small. It may be too small, so maybe you can check this presentation file later. But the Ruby to Ruby, and this table represents for the instance variable opcores, which is just the array. So in each element, you contain one line of code, basically. Okay. And next, I explain some high-level architecture, high-level design. So at this point, maybe it looks similar to the .NET compilation flow, but from now on, it differs. So first, you take this field DSL, and you just input this to the burn. That's same, okay? But from this next, what burn RubyGem will do is that initialize the event machine and then start to run. And these two circles represents for the periodic timer. So there is two timers, two loops. The first one, the one below, is for the screen output. So Telnet terminal will receive the screen output from the periodic timer. And the second one is for the receiving key event from the terminal. And once the event machine receives the key event, then the event machine will just pass that event to the Telnet VM. This is the core part of the Telnet sub architecture. Okay. Remember that I explained that this OPEC calls array, and how this works actually is this part. So basically, every time this while loop works, this next frame, actually this one, next frame method will be called, and then it says that self.instance eval and OPEC calls. And at PC stands for the program counter. So what is happening actually is on every single period of the time frame of event machine, instance eval will be called something like this. So at the first while loop, this line of code will be executed. And next, this one is called, but it's commented out. So internally, it's just a skip. And this one is called, this one is called, this one is called. So it looks like some Newman-like architecture. It's really simple programming architecture. Works like this. And how was the performance about this is I have just interested in about that. So I did some quick check about the performance under the environment, under the condition of the cheapest VM on DigitalOcean, which have the 512 megabyte memory and 1 core and CentOS. And Ruby version was the 2.1.2. And the final outcome was like this. So connection, number of connection. So it means that number of the Telnet client. I only tested up to the 250, but even the Telnet server have 250 client. Load average is the maximum 0.12, which is really good. So I don't think it's scalable or not, but for the personal use, it's good enough. Okay, so the last part is the why I created this. I only have the short remaining time will be maybe 7 or 8 minutes, so maybe I have to tell this in really very short time. Okay. So this kind of scenery is really usual for Japanese family, or I don't know about the overseas. This was 1991, and at my grandparents' house, and this one is me. Was at the elementary school, and this one, no, he is he is my brother. Sorry, and them are my cousins. And you know that this is really our good memory. So when we played the 8-bit game, it was not only to play the game itself, but it was also the communicating with the friends or the family or anyone. So we have very, very good memory about this, and I still love this. And okay, next is this one. This is some breakout on the PC, and my first experience with the terminal was when I was in elementary school, and my parents was giving some NEC laptop to my brother, which is just the 20 megabyte and 386 CPU. And it cost very expensive, I remember. And that caught my attention very much. And that's why I wanted to become a software engineer, and right now I'm here. So when you hear these days, when you hear application development, you might imagine, okay, let's say application development is like to create the native application like iOS or the Android. Or you might think that application development sounds like to create some web application with Rails. It's okay. Or some of you may think, okay, the Windows standard application or something like that. It's up to you, but the low-tech is not that bad, I think. It's long life. For example, Telnet initially developed in the 1969. I'm really surprised about that. And already alive more than 50 years. Correct? No, 40 years. Okay. And .NET lives also for so long, more than 30 years, right? And those of them are the works universally, meaning that doesn't require any specific platform or the vendor lock-in free. So it feels really free, and I love it. So Robin Williams says that why do they call it rush hour when nothing moves? So actually, those kind of the new technology will be born and will be die sometime. I don't know, but some tech still alive, and some of them will long for a long time. So it worth to reevaluate the low tech. So you may have chances to, how do you say? So for of course, for example, for login process, maybe okay, you should not use Telnet because it doesn't have any encryption support. But for the fun use or the simple use, maybe this kind of low tech is still a way. Still useful for you sometimes. That's the reason why I created. It's the first reason. And second reason is that I love free software. And actually, the Burn Ruby gem is provided as a free software, and which is the GPL v3 is the license. And what is problematic around the .NET application development environment is right now when you hear the .NET it sounds like some piracy problematic. So because maybe this should last, right? Because there is no very much homebrewed .NET file. On the internet, if you Google the NES, you will probably find many ROMs, but maybe many of you don't know about the license of that ROM. No one here might actually yes. Yes, no one here is not sure sometimes to use if you can use that .NET ROM or no, because this look Mega Man, but is this license is okay or something like that? So it's better to decide that for us to create our own NES ROM. So that should be license free to license okay ROM, right? So workaround might look like, so maybe soon we cannot solve this problem, but in long term, for example, maybe sometime in some future, maybe far future, if I create some fuel hub, which maybe you can post your fuel to that website so that anyone can download that fuel and burn it and play everywhere like that. So free software thinking makes it possible to share the fun and many things. So that's why. So let's go to the conclusion part. We've seen that .NET compilation process, and which is really fun. Actually, since thanks to the Ruby is really fun. So that's the .NET compilation becomes fun. And Trinity server architecture is looks a little bit childish, but it works. Please try it if you want. And the reason why I created this Ruby gem was that low tech is still good. evaluate is really good. And open sourcing it makes us happier. I have some, this is acknowledgement, means that some images is taken from this site. Thank you very much. And I have many appendix, but I have no time to explain everything. So later, if you have any interested, so just please see these slides, or anytime, please feel free to mention me or mail me. So this is end of my talk. Thank you very much.